the southeast corner of Washington State, 25 miles north of Richland, a first-of-a-kind facility is being designed and constructed to immobilize millions of gallons of radioactive and chemical waste. The waste from nearly 50 years of plutonium production is currently stored in 177 aging underground tanks at the Hanford Site.
Bechtel National Inc. has been contracted by the U.S. Department of Energy to build the Vitrification plant, also known as the Vit Plant. When operational, this facility is going to eliminate the environmental threat posed by this nuclear waste. And we're going to do that by converting the liquid radioactive waste into a solid form, a glass form, through a process called vitrification. Now, vitrification is a proven technology that's safely in use at multiple DOE sites throughout the complex. And by vitrifying this waste, we're going to protect the Columbia River and the millions of people that rely on it for agriculture, commerce, and recreation. This is an incredibly important mission for those of us building the Vit Plant.
In September 2001, construction began on the highly complex Vit Plant. Spanning 65 acres, the plant includes 4 major nuclear facilities: pretreatment, high-level waste vitrification, low-activity waste vitrification, and the analytical laboratory, as well as 20 support facilities and extensive underground systems. A team of highly qualified engineers and other professionals, skilled craft workers, and suppliers from around the globe has been assembled to address the challenges of treating Hanford's unique waste. This expert team understands the importance of performing quality work and working safely. Treatment begins with the transfer of waste from the current storage tanks through an underground pipe-in-pipe system. The waste arrives at the Vit Plant in the pretreatment facility, where it is concentrated by removing water in an evaporation process. Solids are filtered out. The remaining soluble radioactive isotopes are removed by ion exchange. The high-level waste stream is sent to the high-level waste vitrification facility, while the remaining low-activity liquids are sent to the low-activity waste vitrification facility. In the high-level and low-activity waste facilities, the waste is mixed with glass-forming agents to create molten glass. It is then poured into canisters, cooled, and prepared for disposal on-site for the low-activity waste and off-site for the high-level waste. The pretreatment facility will be the world's largest and most technologically complex nuclear chemical separations facility. The building is nearing its total height of 120 feet tall. Huge stainless steel vessels are in place to receive and process the waste. The high-level waste vitrification facility will house 2 90-ton melters to turn radioactive waste into glass. The molten glass will be poured into 14-foot-tall stainless steel canisters. The facility will produce 6 tons of glass per day, about 480 canisters per year. The low-activity waste vitrification facility is structurally complete, and work now continues on its internal systems. 2 300-ton melters will produce 30 tons of glass per day in this facility, for an annual average of 1,100 glass logs. Integral to the vitrification process, the analytical laboratory includes 14 hot cells that, during operations, will process 10,000 samples each year to ensure that the vitrified waste will be safe for long-term storage. The balance of facilities provides all necessary systems to support vitrification. The facilities include a steam plant, chiller compressor plant, glass former facility, and more. Construction is already complete for some of these facilities, and they await final testing and startup.
Steady construction progress continues here at the Vit Plant. 260,000 cubic yards of concrete, enough to fill 75 Olympic-sized swimming pools, 170 miles of pipe, 40,000 tons of structural steel. That would construct 4 Eiffel Towers that'll all eventually be a part of this facility. Currently, we're transitioning from the design construction and beginning the commissioning phases.
Although original planning called for starting all facilities simultaneously, a phased approach to treating waste is being considered. In the phased approach, some facilities would begin operations and waste vitrification as they are completed. This approach would enable waste to be treated as soon as possible and provide operational experience as the other facilities become available to start up. For the waste treatment plant, the multi-pronged phased approach to startup and completion of the mission recommends sending low-activity waste directly to the LAW prior to completion of the HLW and pretreatment facilities. This would allow waste vitrification to begin sooner, compared to waiting until all technical decisions are made and the pretreatment facility is completed.
Many of the challenges here at the Vit Plant have never been faced anywhere else in the world, and our employees are continuing to advance the design and construction of this facility to ensure a safe environmental solution. Maintaining our strong nuclear safety quality culture is a critically important part of what we're doing here at the Vit Plant. Multiple independent review teams comprised of experts from industry, academia, and the national laboratories have been actively involved in the design of these facilities. Our strong nuclear safety quality culture encourages continuous improvement and for employees to bring forward all issues so that they can be resolved, and will help ensure that we'll be able to operate this facility safely and protect the environment and the public.
As the cornerstone of Hanford cleanup, completion of the waste treatment plant is vital in removing the threat posed by Hanford's radioactive liquid waste.